So this is our third. This is my third presentation regarding the topic of CNN on food images. As the topic was how we can execute CNN on my related topic. So my related topic is food image identification using
Try
various
to
deep learning
try to
models.
finish by 10 minutes. Okay.
Okay, yes, sir.
Yeah.
So in this topic, I have given some references. The
Yeah.
first
Keep
references
it.
is this
Yeah.
one.
Keep it.
Skip. In this model, sir, the thing is, first we have to take data, then we have to use some pre-trained
Yeah, that is
model.
common thing. Yeah. Okay. Next.
So this is the image of food
Data
data
set.
set.
Okay.
Example of food data set where we can see various food data set images like food
Okay.
101, UEC food
Yeah. I
100.
understand. Next.
Okay, next is some sample food images where
Okay.
you can see
Next.
various images. And the
Yeah.
second, we have again sample images, which is very important because MA food 121 and food 24 is food data set which I want to use for my future reference. Where in the section A is MA food 121 where you can see various images. But the problem is some of the images contain only one food, but some of the images contain multiple foods. So the main thing is that how we can segment that multiple food in a single plate and how we can calculate calories, how much we have in a particular plate. So that is the main challenge in this work. So this is the whole methodology how we can use. The first we have to take image, then we have to use some convolution neural convolution operation. Then we have to use pooling layer. In pooling we can use max pool by average pool, but we want to use max pool as it gives maximum efficiency or maximum accuracy. At the end, we have to use fully connected layer. So this is the whole model of CNN.
Right.
Now, in this case, we are using the author have used transfer learning. Why we need transfer learning? As because if we start from scratch, we need huge number of resources which we do not have right now. If we use Colab now, suppose 1 or 2 years back, we can use Colab and we can train ResNet. But right now, if we want to train ResNet, it is very time consuming. It will take 1 or 2 minutes for a single report. Also, if I want to upload my data in that collab, it will take too much amount of time. Plus, the most important problem is that after some time it log outs automatically. So again, after log out, again I have to log in and again I have to do the same thing. So that is the main problem we are facing in collab. But transfer learning is that we don't have to train from scratch. We can take a pre-trained model and we can use those weights and for our new data set. Again, in the transfer learning, we are not using the exact model. We can change the last few layers, like the flattened layer and the last dense layer. And it depends on how many outputs we have. Depending on that, we can change the last layer, and using that, we can use pre-trained model for our new data set. So this is how we can change the last few layers, where you can see newly added layers which you can see. So this is the last layer which we need to change depending on the number of output. And the last in the output we have to use softmax activation. Previously we can use ReLU as an activation function, but the last layer we can use software. Why softmax? Because if the number of outputs is more than two, it is seen that softmax gives us a good best result in terms of various activation functions. But previous layers can use ReLU as an activation functions. This is an example of VGG16, which is a model which we can use for pre-trained network. In the VGG16, we can see that the green things are called the convolution neural network. Then plus ReLU. ReLU is an activation function. Then we are using the blue things are called max pooling layer. So if you go through this image, at the end we can see there is a red box. The red box is nothing but softmax, and before that there is a green box which is nothing but fully connected layer plus ReLU. So we can see the last before last layer we can use ReLU, but at the last we are using softmax. Now here 1000 is given, but for our in food image, if we use food 101 as a data set, in food 101 we have 101 classes and each class have 1000 of images. So it should be 101 at the last one. Now this is another model which is Inception V3, where you can see the blue box are nothing but a combination box. The green is max full and the yellow is average full. So you can see that after some time we are separating the whole thing in four various ways. And then the fourth thing, in the first part we are using only one convolution, in the second part three convolution, third part is five convolution, and the last part one average full plus one convolution. Then we have a concatenation operation. Now this concatenation operation is not done only in Inception V3. There is a model called ResNet where we can see this kind of operation. So why we in the ResNet there is this connection. There is a concept of skip connection. So that we there is a thing called vanishing gradient. So that we do not have that kind of problem. That is why we need to skip various layers so that we can create up to the last year. So this concatenation operation is very important. And again, after concatenation, we are passing all those information to the next layer. So if we can do that, at the last we can see there is softmax and there is some dropout layer. Dropout layer is nothing but we are not executing all those nodes. We are by force we are switching off some nodes randomly. So if we can put value like zero point 0.5 for dropout, it means 50% of the node will be dropout, and if we use zero point 0.2, it means 20% of the node is dropout. Why we are doing this? So that we do not have any overfitting problem. So it depends on number of data overfitting. So if the number of data is small, we can get overfitting. If the number is large, then it will not be a problem. So this kind of model author have used for pretend and for transfer learning, so that the author can use this model for new data set. Now these are the various results which author have shown where you can see the accuracy, precision, F1 score and recall. These four things the author have shown, where you can see the VGG is there, and at the end we can see the inception V3. So as you can see, Inception V3 is performing much better than VGG and some other previous deep learning models. So this is my second paper which I have used, which is called Foodical, where the main thing is that again the author have used dataset, and this is the main diagram where the author is used. Where the author have constructed the data by itself, by himself. It means that whatever data the author have used, it is constructed by the author by himself. Then the author pre-process the data. It means it converted to RGB to grayscale. Then after grayscale, author have done normalization. After that, it had the image is used in the model part. Again, the author have used Inception V3. So this is the second paper. In this paper also, author have used Inception V3 model, so that it can get maximum accuracy. So after Inception V3, again it is using transfer learning to train the data, and finally it is saving the model. To save the model, we need to convert the model to .h5. So if you do not use the .h5, then we cannot save the model. Even when we are saving the model, we need to save the model with weights. With weights means so that we can use those pre-trained network or the all weights which are used in the pre-trained network. Now, after saving the model, we are uploading the model. Not we, the author have uploaded the model in the website. And again, in the website there is a button where any user can upload image, and depending on the image, it can give us the output. This is the whole methodology for the second paper. So again, this is Inception V3, which I'm not talking about because I just previous slide. So this is some example which is given by the author, that in this example you can see the food category and prediction percentage. So various food categories are there, but in the prediction percentage you can see that only three values are there: only donut, hamburger, and macarons. Only these three things are showing only 99% accuracy, but the other categories are not showing that much of accuracy. The reason is that these three categories have single data. Single data means single image in a particular food plate. But the remaining category doesn't contain a single image in a plate. So in that plate there are multiple images. From the multiple images, the author have to select which category of image it is. Because it is multiple image, there is a problem of segmentation. There is a problem of 3D accuracy. That is why only three of them is giving us maximum accuracy, as the images is single. There is an example which author have shown that 5, 6, 7, 8, 4 images are there. The first one is when we see the test image number 5, because the pizza, for pizza it is given 97%, for hamburger it is getting 98%, again for hot dog it is getting 89%. But it should be combination of hamburger and pizza, because in the picture you can see that there is pizza, there is hamburger, there is French fries also. Even in the category we are not seeing French fries. So this kind of problem we are facing in this kind of problem, because again in a single plate we are not having a single food, multiple food is there. So how to segment the food perfectly so that we can calculate how much calories are there in the particular place, that is the main concern in my problem. So till now it is not addressed. There are various solutions, but the solution are not accurate. We can mask all those images, that this but in this particular image, this part of the image is pizza, this part of the image is hamburger. But it is not possible to mask each and every image in a 1,000 or 10,000 data set. Again, in the second image 6, we can see that for steak, we are getting 99% accuracy, but there is also some broccoli is also there, but the camera or the algorithms cannot capture that broccoli from this image. Again, this is a fault in this image, so we cannot calculate how much calories in this plate also. The last image 8, it is nothing but hot dog, but not only hot dog, there's some bread is there, there is some Spanish is also there. Again, the algorithm cannot capture all those things and cannot calculate accurate calories. So these are the problems, and these are the two references which I have used. So this is the end of the presentation.
Okay. So